You know that feeling, right? You finish a series on Netflix and boom, it serves up a new show that feels like it was made just for you. It's kind of uncanny, almost magical. But here's the thing, it's not magic at all. It's artificial intelligence. And today, we're going to pull back the curtain and demystify what AI and its powerhouse engine, machine learning, are all about.
So how does Netflix know exactly what you want to watch next? That's really the question that kicks this all off. Because, it's not just Netflix, right? It's how Amazon suggests that perfect product, or how Spotify curates a playlist that just gets you. It's all powered by the same core tech, and by the end of this, I promise you're going to see the blueprint for how it all works. All right, so to really get a handle on those recommendations, we got to start with the big picture, artificial intelligence. Now, I want you to forget the sci-fi robots for a second. At its very core, AI is all about one thing, making machines smart. We're talking about giving them the ability to think, to learn, and to solve problems in ways that kind of mimic how we humans do it.
So let's put a pin in that definition for a second. When we talk about AI, what we're really talking about is building computer systems that can do things that, until pretty recently, only humans could do. Stuff like recognizing your friend's face in a photo, understanding what you're saying when you talk to your phone, or even making a killer move in a chess game.
But, okay, what does thinking like a human actually mean for a machine? Well, it pretty much boils down to these 4 key abilities. First, there's reasoning, logically working through a problem. Then there's learning, which is huge, taking in new info and getting better. Perception is about understanding the world from data, like seeing a picture and knowing, hey, that's a cat. And finally, decision-making, which is taking all that input and making a call.
Okay, and this is a really important point to get. The AI that recommends your next movie is a completely different beast from, say, the super intelligent computers you see in the movies. See, in the real world, AI isn't just one thing. It's more like a spectrum, and we can basically break it down into 3 different levels.
Now take a look at this chart. The column I want you to really pay attention to is current status. Because here's the big takeaway. Every single piece of AI you use today, Siri, Netflix, facial recognition, all of it, is narrow AI. It's absolutely brilliant at one specific thing, but that's it. It's a one-trick pony. The next level, general AI, where a machine can think as flexibly as a human, well, that doesn't exist yet. It's still theoretical. And super AI, smarter than all humans combined, that's pure science fiction for now.
So if everything we've got right now is this super specialized narrow AI, the big question is, how do we actually build it? How do you make a machine so ridiculously good at just one thing? Well, that brings us to the engine that powers pretty much all of modern AI. It's a field called machine learning.
And just so we're crystal clear on how these two things relate, think of it like this. If artificial intelligence is the goal, the car that can drive itself, then machine learning is the engine. It's the powerful, self-improving engine that actually makes the car go. It's the main way we create AI today. And this is what's so revolutionary about it. For decades, the only way to get a computer to do something was to write out explicit, step-by-step rules for every little thing. But with machine learning, we totally flip that on its head. Instead of feeding it rules, we feed it data. Just tons and tons of data. And the machine figures out the patterns and the rules all on its own. It literally learns from experience.
Okay, so how does a machine actually learn from data? It sounds kind of like magic, right? But it's not. It's a set of really clever techniques. And for the most part, these techniques fall into 3 main learning styles, and each one has a totally different approach.
This table breaks it down really nicely. First up is supervised learning. The best way to think about this is like studying with flashcards. You show the machine tons of examples that are already labeled. This is spam, this is not spam, and it learns to spot the difference. Then you have unsupervised learning. This is more like giving someone a giant messy box of Legos and saying, sort these. There are no labels, so the machine has to find its own hidden patterns, like grouping customers based on how they shop. And finally, there's reinforcement learning. This is basically like training a dog with treats. The AI learns by trial and error. It gets a reward for a good move in a game and a penalty for a bad one, and just keeps getting better and better.
Okay, so we've got the concepts down. But how do you actually go from just a huge pile of data to a real working AI model, like that Netflix recommender? Well, it's not some eureka moment. It's a very clear step-by-step process.
And this is basically the blueprint. They call it the machine learning life cycle. First, you've got to collect a whole lot of data. Then, and this is often the hardest part, you have to clean it all up and get it ready. That's pre-processing. After that, you pick your algorithm, you train your model by feeding it all that clean data, and then you have to test it like crazy to see if it's any good. That's evaluation. Only when it passes the test does it get deployed out into the real world, where you have to keep an eye on it to make sure it's still working right.
Now, during that training step, there's this one huge challenge that everyone faces: getting the fit right. And the best analogy is tailoring a suit. Overfitting is when you tailor the suit so perfectly to one person, down to every last weird curve, that it won't fit anyone else. The model basically memorized the training data, noise and all, and it's useless on new stuff. The opposite is underfitting. That's like making a giant shapeless sack. It's too simple, and it doesn't really fit anyone well. The whole game is to find that perfect balance. A model that's like a well-made suit, it just fits. All right, so we've covered a lot of ground. The levels of AI, how machines learn, the whole life cycle. Now let's bring it all back home. Because this stuff isn't just theory in some lab. It is already, right now, completely woven into your daily life.
I mean, it's pretty much everywhere you look, especially on your screen. It's the AI crunching millions of ratings to give you those Netflix and Amazon recommendations. It's the insanely complex network behind Google Translate that doesn't just swap words but understands grammar. And yeah, it's how Siri and Alexa can actually understand what you're saying, no matter how you phrase it.
And it's not just on your screen, it's in your pocket and on the road too. That Face ID that unlocks your phone, that's a super sophisticated AI. When Google Photos can find every picture you've ever taken of your dog just because you search for dog, that's AI. And you know when Google Maps tells you to take a weird turn to avoid traffic? That's an AI analyzing live data from thousands of other phones to find you the fastest possible route. It's wild.
So think about that for a second. In just a handful of years, AI has gone from something in a university lab to being as common as electricity. It helps us find our way, it helps us talk to each other, and yet it helps us find the perfect movie to watch. It's gotten so good at these specific, narrow tasks. And that leaves us with one last massive question. If this is what today's narrow AI can already do, what happens when we point this incredible power to learn at the biggest problems we face? Curing diseases, tackling climate change, exploring the cosmos. What problems will tomorrow's AI solve? Thanks for joining this explainer.